Arrays are one of the most well-known data structures out there, mostly because every modern programming language provides support for it. Yet, during coding interviews, questions about arrays can be trickier than you can imagine. In this video, I will share everything you must know about arrays and how to implement them. Hi there, my name is Ricardo Carrera and I'm a developer advocate here with AWS. Welcome back to this series about data structures. In this episode, I will talk about arrays. I know, right? An entire episode purely focused on arrays may sound a bit too much. After all, this is one of the most well-known data structures out there. And I'm sure that throughout your career as a software engineer, you have implemented many arrays. And because of this, I won't spend too much time with the theory. Instead, I will focus more on interesting things like when you should use an array and what are its advantages depending on the use case. For example, using arrays can be the right answer if your code knows the index where a certain element is stored. And this read operation will be O of 1 or constant time. However, if the use case is more focused on writing than reading, then the array efficiency will be drastically decreased as this operation will be O of n, meaning it will depend on the number of elements stored in the array. To make sure we are on the same page about arrays, let's do a quick recap in the data structure. An array is a fundamental, contiguously allocated data structure. Its structure is composed of fixed-size data records of the same type, such that each element can be efficiently located by its index. They provide a linear form of storage, which is useful for situations where you want to keep a list of related data sequentially. You can think of an array as a street with multiple houses. Each house represents an array element, uniquely identified by its number. Assuming all houses are equal in size and sequentially numbered from 1 to n, we can compute the exact position of each house from its address. Arrays have several advantages. Let's take a look at each one of them. First, they provide constant time access given an index. Because the index of each element maps directly to a particular memory address, we can access arbitrary data items instantly, provided we know the index. Second, they are very space efficient. Arrays consist purely of data, so no space is wasted with links or other information. Further, end-of-record information is not needed because arrays are built from fixed-size records. Third, they provide memory locality. Modern programming languages often provide developers with mechanisms to iterate through all the elements of a data structure. Arrays are good for this because they exhibit excellent memory locality. This means physical continuity between successive data accesses as it helps exploit high-speed cache memory of modern computer architectures. The downside of an array is that you cannot adjust their size in the middle of a program's execution. As soon as you try to add the n+1 data element, where n is the size of the array, your code will fail and throw an error. A way to overcome this problem is allocating a relatively large array so you postpone as much as possible this event. But this is not a very good solution as you will waste space. Another solution is creating a new fixed size array larger than the original one and then copying one array into the other. While this can relatively solve the problem of space waste, and I say relatively because now you are allocating two arrays, so you have to hold those arrays in memory for this to happen, it will change the data structure access pattern to O of n, as copying arrays requires some linear transverse over the stored elements. This happens because arrays are not dynamic data structures. They have a finite, fixed number of elements. You may work with some programming languages where arrays are automatically resized when you add and remove elements, but you must know that this doesn't happen for free. It is not because you didn't write the code for this that this doesn't happen. The compiler may relax the amount of code needed to handle arrays with syntactic sugar but the runtime will certainly take care of this for you. Understanding this is important if you are doing coding interviews. As your interviewer, we want to know if you are aware of this. There you have it. You now are all caught up on arrays. Let's see how they work from the implementation perspective. From the implementation perspective, what we are going to do essentially is to declare an array of integers, and then we're going to initialize this array with random values. So it's always a good idea to start with random values when you are studying, because it's going to give you the chance to perform other operations like sorting, right? And also, we're going to create a set of operations that's going to work on this array to either mutate the values on the array or to change the array structure. These are likely one of the possible questions that you're going to see on coding interviews. You're going to see questions that's going to force you to think how to transverse the array and operate on these elements. Or you're going to see questions that's going to force you to come up with solutions to change the structure of the array, right? What I mean, change the structure, change the size, and then it's going to either add new elements, remove elements, etc., right? So let's start with the most obvious part here, which is the declaration of the array. So I'm going to start with the simple array that's going to be, I'm going to call it my array, and I'm going to initialize this array with 5 elements, not 10, I think 5. So what you just saw is Code Whisperer trying to complete my coding exercise, right? Which is pretty cool. But as I mentioned before, Code Whisperer might whisper some suggestion that it makes sense for your code from the syntax and implementation perspective, but it cannot possibly figure out what your intention. So my intention for this exercise is to create a smaller array to start with. So you can accept the recommendations, but you don't have to necessarily settle for everything, right? So this is our array. So we have declared an array of 5 elements of the type integers, right? So now we're going to initialize the array with random values, right? So for this, I'm going to explicitly ask Code Whisperer to create a method for this. So create a method to init the my array. It's always a good idea to refer to the your code by name when you have name and elements with random values, right? So as you can see here, this is a plain English instruction about what the code should look like. So when you press enter, you're going to see that Code Whisperer is already suggesting that you create a method called initArray. And as you can see here in this 1 by 2, this is the amount of suggestion that Code Whisperer has for you. You can navigate on those suggestions pressing the arrow key on your keyboard. So I'm going to press the arrow key to look further on the suggestions. So this second suggestion is interesting for me. I'm going to hit tab to accept the recommendation. And then, which makes sense because as you can see here, what the code, I'm going to close the for loop and I'm going to close the method. So this method here is essentially creating a loop that is transversing the array from all its elements. And for each element is creating a random number multiplied by 100. And the result of this expression will be an integer that's going to be stored on the array element. So pretty good to me. And we also need to test this, a main method for this. So what I'm going to do is to ask Code Whisperer to create a main method for me. So now you might be thinking, Ricardo, really? Why can't you simply type public static void main? Because this is how you create a main method in Java. Because most of the time, when you have already some code already implemented, if you ask Code Whisperer to do this, it's not only going to create the main method implementation, but also with some code already in it. So if I press enter, you're going to see this. So as you can see here, I can simply accept the implementation, and then it's going to not only create already the initialization of the array object, but also the invocation of the initArray method. So it is a bunch of code that you can avoid by simply incorporating the mentality behind Amazon Code Whisperer, right? Obviously, sometimes is going to suggest for you to do things that's not available yet, which is not necessarily a problem because, as you can see, it's suggesting the use of the print array because it figured, okay, you have an array, you have this array initialized with values, and then now you want to show this array, right? If you simply go back, you can always write this code yourself, right? It's not very difficult, but if you go back to the code and press enter, Code Whisperer will figure that, oh, okay, so there's a method that is missing here, which is a method called print array that it should print all the elements on the array. So as you can see here, it's already suggesting. So I'm going to hit tab to accept this. And then I'm going to hit enter to complete the implementation. So as you can see here, tab again, and then I'm going to close the method declaration. Now we have a new method called print array that we didn't write ourselves. And then with the code that is supposed to do, which is printing the array, which is pretty awesome if you think about it. There's a bunch of code here. All of this we've created without writing a single line of code, only expressing our intentions, right? Sometimes, and don't be annoyed by this, Code Whisperer will create a code for you that's not necessarily properly indented. It's going to make sure that the code is right, but indentation is mostly a matter of preference. So for my taste as a developer, I don't like this I++ here in the bottom. I think it should be here. So you can always fall back to asking your IDE to format the code for you. So to me, this makes more sense, right? Let's see if this code works. So what I'm going to do now is to, let me actually, first, before moving forward, let me compile this project. So it's compiled. And then I'm going to click run here to execute this main method. So as you can see here, it create the array. It printed all the elements. Elements D in the position 0, so it's number 96. Element in the position number 1 is element 84, right? So it's working. But before we actually wrap up this part of the implementation perspective and move forward to the other interesting implementations, I would like to leverage the debug visualizer plugin because I want to show you how you can actually follow up this array in memory with a visual representation of it. So what I'm going to do is to set a breakpoint over here, right? Let me put myself here on the bottom so you can see whatever I'm going to show here on this area. And instead of clicking run, what I'm going to do is to click debug to obviously start a debugging session. Now the code is waiting to be executing this line here, so it stopped its execution. But before moving forward, what I'm going to do is this. I'm going to select the object array, right? I think actually let me execute only this step to create the object. Now the object has been created, it's not null. And I'm going to select it and then invoke Code Whisperer. I'm sorry, not Code Whisperer. I'm going to invoke Visual Studio Code commands to invoke the plugin debug visualizer, right? If you invoke the command debug visualizer with this option, use selection as expression, is going to use whatever you're selected right now, which is the object array, and build the debug visualization from this object, right? So I'm going to hit enter. And as you can see here, this is the visualization of the array. So we have the array here. How many elements you have? We have 5 elements. So it's not a coincidence. This array has 1, 2, 3, 4, 5 vertices or leaves, if you want to look as a tree, if you want it, right? But all the elements are filled with 0 because, as I mentioned before, it's the default in Java. So what I'm going to do is I'm going to continue the execution of debugging to bypass not bypass, actually to execute the init array. Look what happened with this over here. So I'm going to execute. I don't want to see emojis right now. And I'm going to execute. And look that the visualization already changed and starts showing you all the values that are stored in the array, even before you execute the method print array. So if I continue the execution, no surprise, is going to simply print all the elements that you were already seeing here. And this diagram, you can actually click on the elements and move as you want it. And you don't necessarily have to use this use selection expression. You can type whatever you want here. So everything that you have here in the debugging session, that is an object whose scope is still reachable for the debugging session, you can simply type here. It's going to show up in the diagram. So this is pretty cool if you want to see what's happening in a code level. So I'm going to resume the execution. So the debugging process just finished. All right, so now let's talk about how to change the structure of the existing array to add or remove elements. So our first exercise that likely is one of the questions that you might have in a coding interview is how to add an element to the end of an array, which means you're going to take the current array and add a +1 element, right? That's going to force you to change the structure of this array. So to this, I'm going to actually ask CodeWhisperer to generate an algorithm for us. So let's see how this goes. So create a method to add an element, a new element. Let's be explicit with our words. To the end of my array. So let's hit enter, and then let's see in the list of recommendations what he has for us. Okay, I like this one because the word add elements and the algorithm is already starting to make sense. Okay, I'm gonna keep accepting the suggestions. Okay, so let's review the code here just for a second before we move on. It's going to create a new array. Basically, it's going to use this array as a buffer to store the elements of the older one before doing the operation of inserting the actual new element, which kind of makes sense. And then it's going to create the size of this array. Remember, it has to be always specifies a size so you don't waste space. It's going to be the existing array length +1, so including a new position, and then you're going to transverse the current array, which is good, and store in the new array in the same positions the old value storage. And then it's going to associate the reference to the new array. I think this is almost right. I would only remove this here and do this after the loop. And why is that? Because Java used the concept of references. An array is basically a reference, such as like a pointer in other object-oriented programming language. If I do this within the loop, I'm going to all of a sudden lose the reference and the pointer to my original object created. So it's better if you simply copy and then switch the references later. I think this makes more sense. So this is what I meant by sometimes CodeWhisperer is going to be the best effort to suggest you the code, but it cannot possibly know what you have in mind. So I think that's the trick. It's going to whisper you the huge majority of the code, so it's going to offload a little bit of your implementation after, but you are in control ultimately. You can always criticize the code generated and adapt for your specific scenario. Now that we have an element, let's go back to the main method. And after printing the array, we're going to do this. We're going to most likely, CodeWhisperer is already suggesting maybe you should add a new element here because you have a method that does this. So let's add the element 14. I like this number. I have a story about this number. That's why I must prefer a number. So if you're curious about it, put here in the comments if you want to hear the story about the number 14. But then we're going to print the array after this. So yeah, here we go. Let's see how this goes with the debug visualizer. So I'm going to put a breakpoint right here, exactly before the execution of the add element, and I'm going to start a new debugging session. So if I select the array and then invoke the debug visualizer, here are the existing elements. So, but more importantly, we have 1, 2, 3, 4, 5 elements in this array with values already. And then I'm going to execute the add element. So let's recap what just happened here. And it seems that it worked because now we have 1, 2, 3, 4, 5, 6 elements. So the array changed its structure, and now all the existing values were already stored, including our lucky number 14, right? So now if we print the array, we're going to see that all the elements stored before were there, but now copied to the new array. So this is how you usually are going. Let me resume the execution. So how you're going to usually solve this problem in a coding interview, you're going to create a new array, iterate over the existing array, and then copy the elements one to the other, and then adding to the last position of the array the new element, right? So this is one way to do it, right? Especially if you're using an array whose structure is static, right? So now what we are going to do is do something that is similar, and you're going to see that the implementation is fairly trivial, but in this question in coding interviews, most people got confused about the complexity of the algorithm, and I think that's the problem, because maybe you were thinking that you were going to come up with something like fairly advanced and fancy, and most of the time, and here's the trick, in coding interviews, most of the time they're not expecting for you to be clever. They want to be effective, right? So the new exercise is going to be adding a new element to the existing array, but in the middle of the array. So let's see how this goes. So let's ask Code Whisperer to generate a method for this. Create a method to add a new element to the middle of my array. Let's hit enter and see the suggestion. Okay. None of the suggestions seems to be interesting so far, because I don't want to come up with the index to resolve this. And add a new element to the end of the array. No. Okay, so if none of the suggestions are doing what you want, what you can do is always start the implementation yourself, because the method signature is add element to the middle. I want you to simply specify that I want a new element, and the algorithm should figure it out how to do this. So you can force Code Whisperer to continue your line of thinking here, just like I'm going to do now, by pressing Option C. And then it's going to basically generate a pseudocode for you that's going to suggest how to solve this problem. So let me see which implementation here. I think this one is interesting. You see, this one here is essentially kind of a solving the problem, because it's going to read the array, do some array copying, just like the add-in of the new one, but then it's going to basically iterate over twice. So this iterating over twice is something that we want to avoid in algorithm implementation. So I'm going to go back to this one, because this one seems to be more clever. Okay, I'm going to accept this and see how this goes. So let's review the code. Creating a new array. The new array is going to be the position of the existing 1 + 1, just like the other one. Copy all the elements, do the reference switching to one point to the other, and then precisely, instead of iterating over the new array, is going to do this. It's going to come up with the length of the new array, which is now the my array, because we've replaced the references, and divided by 2, it means that we are pointing to the middle of the array, and then store the new element. So we're basically replacing the existing element, whatever this element is, in the middle of the array. Let's see how this goes to test it. So instead of add a new element, I'm going to ask to invoke add new element to the middle. So we're going to add the lucky number 14. Let's see how this goes. Let's debug, and then, so our current values, let me see with the debug visualizer, our current values are 57, 65, 42, 69, and 2, right? And then what we're going to do is add element to the middle. Let's execute this. And let's see how this works. So we still have 1, 2, 3, 4, 5, 6. And then we have 6 elements, but now we have the number 14 start on the third position, which is roughly, yeah, it makes sense because now the element has 6 elements. So the middle is going to be the position number 3. Makes sense. Okay. So in this case, I think it works. I think the only thing that I am looking here, and that's one of the value of using the debug visualizer, is that as you can see here, the 5th position wasn't copied. So likely we've lost some elements. Let's see which elements we've lost here. 57 is there, 65 is there, 42 is there, 69. So 69, it should be the 5th position here. And the number 2 is here and the new position. So with the implementation that was generated, it was ineffective. So this is a very interesting case where you should, like, that's one of the values. That's what I would like to see you show you the debug visualize, because you can actually use this to kind of criticize mentally the implementation. So not all the time, just because Code Whisperer suggested you an implementation, the implementation will make sense for what you're trying to do. And this, by all means, that doesn't mean that Code Whisperer is not doing its job. It is doing marvelously, right? It's almost fantastic how it does this. But the problem is the algorithm, the real logic of the program. Only you knows this, right? So as long as you start like putting more effective sentences in your questions, Code Whisperer cannot help you much. But most importantly, talking about Code Whisperer is during the coding interview, situations like this should not be cause of panic to you, because this is the whole point. You should like being able to look and criticize on spot and say, you know what, dear interviewer, I think this is not going to work because we're going to lose one of the elements. So let me change this to this other algorithm here to see how it goes. This is exactly what the interview wants to hear. You being able to be not only effective, but also analytical, right? You don't have to settle for everything that has been sent to you. So this is a good example of how a coding interview should look like. You should be able to spot syntactic and functional problems with your implementation, right? And sometimes the coding interviewers might look like and say, you know what if this other element is lost in the middle of implementation? And you should listen to them because they're giving you tips about what can you possibly change in your algorithm. And speaking about algorithms, let's practice now some of the algorithms that you should know about the data structure you are being tested about. So this is one of the trickiest part when you're studying data structures, because you have to learn not only the data structure, but the algorithms that somehow are connected or related to that data structure. And for example, in the case of arrays, chances are that you are going to be tested in some of the sorting algorithms that you should know for your coding interview. So let's practice with some of them right now. I'm going to close the debug visualizer once again, and then let's add a new method to our code. And this method is going to sort the array using a very known sorting algorithm called bubble sort, right? So let's see how Code Whisperer generate this code for us if we ask it explicitly. So create a method to sort my array. Good suggestion. It's using bubble sort. Yeah, it's figured out what I'm trying to do. Okay. All right. Good. Okay. So there are 2 possible implementations here. The first one is not using the -1. I think I'm going to use this one because I know that if I accept this, I'm going to try to access the position of the array and end up with an index array out of bounds exception. So, okay. Okay. Let's continue the acceptance of the suggestions. Don't need to print array, but I'm going to accept it for now. And then, okay, so these 2 print arrays here are unnecessarily, like I mentioned before, and I'll be repeating here throughout these years. You don't always have to settle for what Code Whisperer suggests you. It's suggested because perhaps someone did this before, and he kind of tried to, okay, maybe is your intention to do this, but it is not mine. So you can always remove the code. And I'm going to format the document because the structure of that for loop was not very nice. I have a problem with this syntax indentation, as you can see here right now. Let me know in the comments if you are one of those people like me that when you see a code that's not properly indented, like it give you the choose, you know, like you don't like it, this type of stuff. Either way, sorry about that. So the sort array is going to use bubble sort, and what bubble sort basically does is iterate over the existing array, and for each iteration of the outer loop, there will be an inner loop that is going to perform the actual algorithm implementation, which is comparing each element, the current element with the element next in the sequence of the array. And if one is higher than the other, is going to swap their position. It seems to be what bubble sort usually does, right? So I think this is awesome. I'm going to simply invoke that method here. I'm going to replace this add element to the middle because we don't want to mess with this right now. So in between one print array and the other, we're going to simply sort the array, right? So we're going to print one, sort the array. I'm going to put actually some separation here for us to see the difference in the numbers. This is one of the most common debugging exercises we can do, because you know that otherwise all the numbers will be printed out in sequence. And then, but in this here, I'm going to put a breakpoint to use the debug visualizer. So let's debug the code again to see if the, okay, so the array has been printed. Okay. Well, first of all, let's invoke debug visualizer. I probably put the breakpoint in the wrong position in the wrong time, but anyway, it doesn't matter. It has been printed, so the elements were 68, 3, 84, 87, 68, definitely not sorted. And then we sorted, so in here in the array itself, they are ordered and sorted. We just need to print one more time. So let's do this now, the separation, and then in the second print, they should be displayed as ordered. So 3, 68, 78, 84, 87. It seems to be sorted to me, which is good. And this is interesting because this, in a real coding interview, this moment, let's call it this milestone of the interview, might be some sort of like a mental celebration for you because you were able to solve the problem that you've been asked to solve. But the interviewer probably is going to throw you a jab, and this is expected. This is not because, because they're bad people. No, because they want to measure the depth of your knowledge, right? And how you can apply that knowledge to real life problems. And in this moment, let me finish the debugging here. In this moment, they might ask you, all right, great, you solved the problem for an array that is size of 5 elements, but what if this array was not only 5 elements, but it would have 5,000 elements? Would you keep this implementation or would you change anything, right? Most likely they're not going to ask you, and what would you change, right? They're going to imply that something has to be changed here, but it's going to give you a hint that something needs to be made to address this, let's call it new circumstance of the problem, right? So, and if you think about it, this is how like life is. You start measuring the resolution of your problem through a single perspective, and then you keep adding more perspective, and then you're going to evolve your problem. And sometimes you might realize you're going to evolve your solution, not the problem. The problem is going to continue to evolve always. But sometimes you might realize that, yeah, so for considering this new perspective, my implementation has to change because the solution no longer applies. So one of the things that you have to be ready for is to change the usage of the current algorithm. So bubble sort is known for having a very simple implementation and resolution. So basically it's a combination of a for loop and an inner loop, right? Not very difficult to understand for the code perspective, but it's not very efficient because if the data set is higher, it's going to iterate repeatedly over all the elements transversely and spend a very long time doing this, right? So a known, more efficient algorithm for larger data sets is the merge sort, right? So let's see how the merge sort would do this. So let me create a new method here. Create a method to sort the my array using selection sort. Maybe later. Let's use merge sort for now. Merge sort. Okay. So let's see how this goes. Okay, so this is the implementation so far. And then let's continue with the acceptancy of the suggestion. So here we have two implementations. That first is going to do a merge sort, and mind that this method here, merge sort, currently doesn't exist. So Code Whisper knows this, and if you accept this, either the signature of the method is going to create thereafter for you. So don't worry if you're using Code Whisper in situations where it's suggesting something that doesn't exist, and you don't have to instinctively say, oh no, this is wrong because it doesn't exist. It will complete the code for you. It knows that it will generatively, like interactively, the code for you. It's one of the beauties of generative AI technologies. So in this case, I'm going to accept this version of the code. I'm going to hit tab, and the compiler is going to say, oh, merge sort doesn't exist. But like I said, that's totally fine. If you hit enter here after the method, it's going to start the suggestion for you of, oh no, you need a method called merge sort with this signature here. So it's pretty awesome, right? So I'm going to accept it. And then I am going to keep accepting the implementation. So, okay, once again, and then makes sense. Again, it's suggesting the usage of another method called merge that doesn't exist, and I'm going to accept it because I know that Code Whisper never disappoint. And then I'm going to simply hit enter one more time to start with the acceptancy. Here we go, with the merge method that was just created. So okay, I'll keep accepting. Okay, so surprise, surprise, you are seeing right now that the implementation is a bit more complex than the merge sort, right? Okay, so a bunch of comments that seems to be unnecessary to me. Okay, so far, so good. I'm going to remove all those comments once we finish, but so I think so far we just need to, okay. Before we walk over the implementation, let's remove those comments because they're not seen. They are definitely unnecessary. Okay, so now for the compiler perspective, everything is working. So let's see how this goes. So the merging, the sort with merge. Well, first of all, let's do this. You know, I'm a visual person, so let's see. Let me see if this sorting is working, doing what it's supposed to do, and then we go back to the implementation. So let's do this. So instead of call sort array, I am going to simply sort with merge sort. Yep, that's the one. And now I'm going to put the breakpoint in the right moments before the sorting and call debug. All right. Debug visualizer, all the values are here. Let's print the array. So it printed unsorted. Let's call the sort, which did the sorting, the merge sort implementation. Let's put the separator, and then let's print if the elements are sorted. Seems to be 4, 13, 38, 82, 93. So yeah, it did what it's supposed to do, halfway of the battle. Now let's understand the merge sort implementation. So the merge sort is usually about two things: splitting the array into multiple slices, as well as using recursion, right? So as you can see here, it created a new temporary array. So just like we did like when we were changing the structure of the array, sometimes you have to create like those like buffers and temporary arrays to work with. Then it's going to iterate over into all the elements and store on this array, and then pass this new array as a reference. I don't think this is actually necessarily, if you think about it. That's some sort of an area of optimization, right? Because we could simply call merge sort with the existing array and simply pass as a reference. I'm assuming that perhaps this implementation came from the assumption that the subsequential method probably will operate on and perhaps even mutate the existing elements, and that could be dangerous because it could jeopardize the consistency of your existing data. But that's one of the things that that's a great opportunity for you to talk back with your interviewer and clarify the question. This is important. Sometimes you don't have to be just sitting there on mute mode and doing the things and walking over implementation. You have to clarify questions. They love this because in real life, they want to know as communicative as you are, and how do you express your thoughts and assumptions out loud. So anyway, in my opinion, it's not necessarily, but this could be a very good area of conversation for you in the interview. So it calls the merge sort. Okay, here's the merge sort. So it's going to receive the array, the start and the end. The start is 0, the end is the length of the array. Sounds good. If the start equals to the end, so basically there's nothing to sort, and then we're going to come up with a new array with the new implementation. And again, another area of optimization because it's creating a new array, perhaps unnecessarily, but again, we have to assume that the intention is not to mess with the data consistency. So that's one of the things. So the merge sort basically is going to calculate the middle of the array and then break down the array into 2 slices, right? The left and the right. It's like you are grabbing the array and then you are doing this, breaking down into multiple parts. And for each part is going to call merge sort. So that's why we call that the merge sort algorithm is a divide and conquer, because it's going to use recursion, because as you can see here, the merge sort is the same method that we're evaluating now. So it's calling itself again, but for each one of the slices of the array. So it's going to perform some recursion. And in memory, this is probably not likely, is going to be using the stack of your program execution. So then when each slice is finally sorted, it's going to merge them back. That's why it's called merge sort, right? Because it break it down, sort individually, and then merge the results back. And then what the merge results back does is essentially kind of walk them over, because now here's the problem. You now have to merge back, but this merging process has to take the consideration that if you simply merge them, it has to put them in a sorted sequence. You cannot simply join them as if they were already sorted comparing with the other, because at this point, the sorts that happen individually has no awareness of the other part or the other slices, right? So what it needs to do is to merge them, definitely, and now I understand why it created temporary buffers, because as you can see here, it's definitely doing a lot of mutations on the array. So if we pass a reference to the original one would probably break something if other algorithms or data or methods would operating on that array. So it's kind of a best practice to create a copy on what you want to mutate. So that's one of the things you can do. But again, the point is, before actually merging the element, it has to merge, but making sure that the 2 sides, once merged, will be sorted back again, which is conceptually, and that's the beauty of algorithms, that you have a pseudo implementation in your brain that, all right, if this slice is merged and this slice is merged, the amount of sorting that I will have to do this is smaller, right? Because they have been sorted already individually. And this is something that allows you to think recursively, because if you have a very large data set with a number of elements, you can think, okay, I'm going to break down into multiple halves, that in each half is going to operate in a very small set of data mates. So conceptually, it's faster, right? And chances are that you won't need to transverse the entire array. Not even chances are. Let's look to the algorithm and not even wonder. Let's be concrete about this. I will break at least in 2 halves the merge sort. So it's already dividing by 2 the complexity of the implementation. So this is one of the things that is interesting for you to know when you are interviewing, because knowing different algorithm implementations allows you to kind of create a belt of utility, like a Batman, of possible implementation that you can work with and apply to your coding interview. Of course, you cannot simply like us keep trying one by one and see which one is going to fit. You have what the interviewer wants for you to know is that if you are able to give in a context, in a scenario and a problem, you can choose the best one, right? And usually it's going to happen what I've mentioned before. Even when you choose the best one, it's going to throw you some jab and say, okay, but let's change this. And then let's see what is going to happen if you are if that circumstance changed. And here's another tip for you. They're going to usually do this if they are still unsatisfied with you talking to them, right? If you, for example, are very communicative and you are talking your thoughts concisely and you're expressing and explaining as you go through the implementation, and by the way, this is what you want to see from you, they're probably going to simply wait until you to solve the problem and be done with it. If you don't do this very often or very well, think about this. There's these jabs that they're going to throw at you that might seem that they're not being fair to you. Think about this as they giving you a second chance to fix that mistake, right? So ultimately, remember, you are not there just to show them that you are a good problem solver and that you are able to memorize different data structures and algorithms. You are also there to show to them that you can communicate, right? Because chances are that you're going to be required to work in a team. And this is important for a software engineer. That's one of the most important skills nowadays. Let's wrap up what you have seen in this episode. Arrays are a sequence of variables of the same type, arranged contiguously in a block of memory. They provide a linear form of storage, ideal for situations where you need to instantly read the data using an index, and to transverse the elements back and forth sequentially. Reading an element from the array is a constant time operation, and sorting its elements is usually O of n. Some divide and conquer algorithms, like the merge sort, can reduce this to O(n) log of n by splitting the array into multiple slices and then using the principle of recursion. My suggestion for you is to keep practicing different sorting algorithms with arrays and use Amazon Code Whisperer to assist you with the code generation. Then spend some time studying the generated code and, whenever applicable, criticize and correct the code. In the next episode of this series, we will take a look at a variation of an array called matrix. If you start watching this series from the playlist, the video about matrices should start pretty soon. If not, I put the link to the video in the description below. See you in a bit.